Welcome to my presentation. This presentation is part of the playlist, The Quadratic Formula. In this presentation, we will be solving problems related to the quadratic formula. Let us say we have an example of this kind. We want to solve this quadratic equation x squared plus 7x minus 330 is equal to 0. So we want to first of all identify whether this given equation is in the standard form of the quadratic equation. This is indeed in the standard form of the quadratic equation. It is of the form ax squared plus bx plus c is equal to 0. So we want to identify the values of a, b, and c from here. The value of a is equal to 1. The ones are implied. 1 x squared means 1x squared. The ones are implied. So the value of a is equal to 1, the value of b is equal to 7, and the value of c is equal to 330. So once we have identified, we're going to substitute that into this quadratic formula and then simplify it and then arrive at our answer. So let us see how we can do that. As a first step, we identified the values of a, b, and c. I have written it down here. A is equal to 1, b equals to 7, and c is equal to 330 or 330. So now we're going to, as in step 2, we're going to substitute the values of a, b, and c into this quadratic formula. The quadratic formula is stating that x is equal to minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. Since the formula is asking for the values of a, b, and c, therefore, as a first step, we have identified the values of a, b, and c, and then as a second step, we're going to substitute the values of a, b, and c into the quadratic formula, as you can see here in step 2. So for the formula has minus b, minus the value of b is 7, plus or minus the square root of b squared, the value of b is 7, so 7 raised to the power of 2 minus 4ac, 4 times the value of a is 1 and the value of c is negative 330, the whole thing divided by 2a, the value of a is 1. We have successfully substituted the values of a, b, and c into the formula. Now we're going to simplify them. Now we're going to simplify it. So negative 7 plus or minus the square root of 7 squared is 49. Then we want to simplify this part of it. Negative 4 times 1 times negative 330. Negative times negative is a positive. 4 times 1 is 4. 4 times 330 is 1320. 1320. The whole thing divided by 2 times 1 is 2. Now we're going to simplify it some more. Negative 7 plus or minus the square root of, we want to add 49 plus 1320 under the radical term. So 49 plus 1320 is 1369, the whole thing divided by 2. So negative 7 plus or minus the square root of 1369 is equal to 37. The square root of 1369 is 37, the whole thing divided by 2. So there are two solutions for this particular equation. Negative 7 plus 37 divided by 2, or x equals to negative 7 minus 37 divided by 2. Negative 7 plus 37, when we simplify that, it is going to be 30 divided by 2, or negative 7 plus negative 37 is negative 44 divided by 2. So when we simplify 30 divided by 2, that simplifies to 15. When we simplify negative 44 divided by 2, that simplifies to negative 22. So therefore, the two solutions for this particular quadratic equation are x is equal to 15 or x equals to negative 22. Both these solutions should satisfy the given equation. Let us check them out. So we're going to substitute x equals to 15 into the given equation and see whether that satisfies the given equation. And then also substitute x equals to negative 22 and then see whether that solution also satisfies the given equation. So our given equation is x squared plus 7x minus 330 is equal to 0. Wherever we see x, we're going to substitute the value of x equals to 15. So 15 raised to the power of 2 plus 7 times 15 minus 330 is equal to 0. So 15 raised to the power of 2 is 225 plus 7 times 15 is 105 minus 330 is equal to 0. So when we add these together, 225 plus 105 is 330, minus 330 is equal to 0. So the left hand side is equal to 0, and that is equal to what we have on the right hand side, which is equal to 0. So therefore the value of x equal to 15 is a true solution of the given equation. Okay. Now we have proved that the first solution is a true solution. Now we're going to check whether the second solution, x equals to negative 22, is a true solution or not. So our given equation is x squared plus 7x minus 330 is equal to 0. So wherever we see x, we're going to substitute the value of negative 22. So negative 22, the whole thing raised to the power of 2, plus 7 times negative 22 minus 330 is equal to 0. Negative raised to the power of 2 is positive. 22 raised to the power of 2 is 484. And then positive times negative is a negative. 7 times 22 is 154, minus 330 is equal to 0. So when we simplify this, we have 484 minus 154 plus minus 154 minus 330 is minus 484. So the left hand side is equal to 0, and that is exactly equal to what we have on the right hand side, which is 0. Therefore, the value of x equals to negative 22 is a true solution for the given equation. So there will be two solutions whenever we solve a quadratic equation. Let's look at another example. Let's say this time we have a quadratic equation of the form 3x squared plus x minus 10 is equal to 0. So this equation is in the standard form of a quadratic equation ax squared plus bx plus c is equal to 0. We want to identify the values of a, b, and c. The value of a is 3, the value of b is 1, the value of c is negative 10. The value of b is 1 because the coefficient of x is 1. The ones are implied, so we normally don't write 1. If there is nothing in front of x, it means 1x. Okay, so that's the reason why the value of b is going to be equal to 1. And once we have the values, we're going to substitute that into the quadratic formula. And then once we have successfully substituted the values, then we're going to simplify it and then arrive at our answer. As a first step, we have identified the values of a, b, and c. I have written it down here. A is equal to 3, a is equal to 3, b is equal to 1, b is equal to 1, and then c is equal to negative 10. Okay, once we have those values, we're going to substitute these values into the quadratic formula. What is the formula? The quadratic formula is stating that x is equal to minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. The value of b is 1. The formula comes with a negative sign, so therefore negative 1 plus or minus the square root of b squared. The value of b is 1 raised to the power of 2 minus 4ac. 4 times the value of a is 3. The value of c is negative 10. So we have divided by 2 times a. The value of a is 3. So we have successfully substituted the values of a, b, and c into the quadratic formula. Now we're going to simplify them. Okay, let us see. Negative 1 plus or minus the square root of 1 squared is 1, and then negative 4 times 3 times negative 10. Negative times negative is a positive. 4 times 3 is 12. 12 times 10 is 120. Divided by 2 times 3 is 6. Okay, now we're going to further simplify this. Negative 1 plus or minus the square root of 1 plus 120. 1 plus 120 is 121. So negative 1 plus or minus the square root of 121 divided by 6. The square root of 121 is 11. So we can write this as x equals to negative 1 plus 11 over 6, or x equals to negative 1 minus 11 over 6. So that's what this plus or minus means. So once we have done that, we're going to simplify it some more. So negative 1 plus 11 divided by 6 is 10 over 6. And then On the other side, we have x equals to -1 minus 11 over 6. That simplifies to -12 over 6. So therefore, when we simplify this, 10 over 6, 10 and 6 are multiples of 2. So 2 times 5 is 10, and then 2 times 3 is 6. So therefore, we can write in its simplest form, 10 over 6 simplifies to 5 over 3, or x equals to 12 is multiples of 6, so therefore x equals to -2. So the two solutions we have are x equals to 5 over 3 and x equals to -2. Both these solutions should satisfy the given equation. So let us check them out. So let's take 5 over 3 first and then see and substitute that into the given equation and see whether that satisfies the given equation or not. So the given equation is 3x squared plus x minus 10 is equal to 0. So 3 times the value of x is 5 over 3, that whole thing raised to the power of 2, plus x, the value of, we're going to substitute the value of x as equal to 5 over 3, which is that, minus 10 is equal to 0. So we're going to simplify that some more. 3 times every one of these terms is raised to the power of 2. 5 raised to the power of 2 is 25. 3 raised to the power of 2 is 9. Plus 5 over 3 minus 10 is equal to 0. So we'll simplify it some more. 3 and 9 are multiples of 3. 3 times 1 is 3. 3 times 3 is 9. So therefore, 3 times 25 over 9, we can write it as 25 over 3 plus 5 over 3 minus 10 is equal to 0. Now we have fractions and a whole number, so we can take a common denominator. The common denominator is equal to 3. For the first fraction, the numerator part is 25. For the second fraction, the numerator part is 5. And then for the third number, 3 times 10 is 30 divided by 3 is equal to 0. As you can see, 25 plus 5 is 30. 30 minus 30 is equal to 0. Therefore, the left-hand side is exactly equal to the right-hand side, and therefore, the value of x equals to 5 over 3 is a true solution for the given equation. Okay. Now let us take the second solution and then also check whether that satisfies the given equation. So when x equals to -2, we're going to substitute that into our given equation, which is 3x squared plus x minus 10 is equal to 0. So wherever we see x, we're going to substitute x equals to -2. 3 times -2 raised to the power of 2 plus -2 minus 10 is equal to 0. So 3 times negative raised to the power of 2 is positive. 2 raised to the power of 2 is 4, minus positive times negative is a negative. So 2 minus 10 is equal to 0. 3 times 4 is 12, minus 2 minus 10, that is equal to -12. -12 plus 12 minus 12 is equal to 0. So therefore, the left-hand side is exactly equal to the right-hand side, and therefore, the value of x equals to -2 is a true solution of the given equation. So therefore, there will be two solutions whenever we solve a quadratic equation. In my next video presentation, we will be solving more problems related to the quadratic formula.